Welcome to This Explainer. Today, we're completely flipping the script on how we think about AI compute. You know, for a long time, the cloud bill has basically been treated like the weather, right? It's just something that happens to you, something you just have to pay and complain about later. But today, we're diving into AI FinOps, financial operations, and we're going to start treating that GPU spend as an engineering problem, something we can actively optimize and bring way down. Because the gap between what teams should be spending and what they actually spend, it's absolutely enormous.
So let me ask you, are you paying for GPUs while you sleep? If you're running AI workloads right now without strict financial operations in place, the answer is almost certainly yes. We're going to highlight this massive gap between your potential efficient spend and your actual cash burn. Closing that gap has actually become its own highly sought-after specialization inside AI infrastructure.
All right, let's jump straight into Section 1, the AI sticker shock.
Look, we've got to address the elephant in the room. Pricing has become incredibly expensive and wildly volatile over the past year. AWS recently raised their GPU prices for the H200. Now, why is that such a big deal? Because they haven't done that in 2 decades. For 20 years, the trend in cloud compute was generally downward, or at the very least stable. And now, that trend is officially broken.
And over on Azure, their H100 on-demand pricing is hitting up to a staggering $13 per GPU per hour. Think about that for a second. If you string a few of those together for a training run, you can practically hear your budget evaporating. So it's really easy to see why the sticker price pressure is very, very real for engineering teams right now.
Which brings us to Section 2, the real cost culprit.
Here's the massive twist, though. The real cost problem, it isn't actually the hourly rate, it's utilization. For a lot of teams, average GPU utilization is hovering around a measly 5%. That means 95% of your budget is effectively wasted while those incredibly expensive chips just sit there. They're idling between jobs, they're idling while a developer tries to debug a script, or they're just left spinning overnight doing absolutely nothing but racking up massive charges.
Because of this incredibly low utilization, the effective cost of your cloud GPU is nowhere near the sticker price. If you're only actually using the compute power 5% of the time you're paying for it, well, your effective price is essentially 20 times higher than what that hourly rate suggests. You aren't paying $13 an hour for compute, you're paying a massive premium for idle time. In fact, current estimates show that leaving these expensive GPUs running while you step away for a meaningless corporate meeting or while you're just deep in a debugging session wastes roughly 30 to 50% of total cloud spend. That is a staggering leak in the budget. Before we even talk about finding a cheaper region or migrating to a different instance type, the absolute highest leverage fix you can make is just making sure you aren't being billed for a parked car.
Let's move into Section 3, stopping GPU waste.
Since we know the leak is massive, the cure starts with infrastructure discipline. First up is a concept called GPU sharing, or multi-tenancy. This means running multiple smaller jobs on a single GPU. Honestly, it's basically carpooling for your compute. Instead of dedicating an entire massive H100 chip to a tiny task that only needs a fraction of its memory, you share the resource. This stops you from locking up entire chips unnecessarily.
Next up is scale to zero. This is an absolute game changer of an automated pattern. Simply put, it automatically shuts down your GPU resources the precise moment your workload stops and spins them right back up on demand when a new job hits. It completely removes human error from the equation, meaning you will never accidentally leave a machine running over the weekend again. You can also tap into spot instances, sometimes called preemptible instances. This is heavily discounted cloud compute that the provider can essentially yank back from you on short notice. But if you've got workloads that are interruption tolerant, like a massive batch training job that periodically saves its progress, spot instances lets you snag compute for a fraction of the on-demand price. It's a brilliant hack if your architecture can support it.
And here is the power of FinOps in action. Teams that actually deploy these automated tools, things like idle detection, scale to zero, and GPU sharing, are seeing 40 to 70% reductions in their effective compute cost. And honestly, the best part? They're achieving these massive savings without touching their underlying model architecture at all. It is purely the result of strong infrastructure discipline.
Moving on to Section 4, Inference Economics.
So we're currently watching one of the most dramatic cost curves in tech history unfold right now. Back in late 2022, running a top-tier GPT-4 class model cost roughly $20 per million tokens. Now, projections and current trends show that by early 2026, achieving that exact same equivalent performance will cost just 40 cents per million tokens. That's a roughly 1,000x reduction in cost in a little over 3 years. We are quite literally witnessing historic technological deflation in real time.
To accurately track this massive tech deflation for your own projects, you use the metric cost per million tokens. This has become the gold standard unit for comparing inference costs across different models and different cloud providers. Why? Because it normalizes the price tag based on the actual work that was done, rather than just the time the machine was turned on.
But here's the catch, and it's a big one. Despite that incredible 1,000x drop in price, inference is still going to completely dominate your total AI compute budget. It typically runs at 15 to 20 times the cost of training. Think about it. Training is a one-time or maybe periodic event. But inference, that happens continuously in production, every single time a user interacts with your product.
Okay, Section 5, your FinOps action plan. Now that we've broken down the massive waste and the shifting economics, let's get into your action plan. First things first, keep the definition of utilization front and center. It's the percentage of time a GPU is actually doing useful work versus just sitting there billing you. Checking these actual utilization numbers on your cloud dashboard is always your highest leverage fix. Seriously, don't assume the instance type is wrong. Assume your utilization is low.
So here's your immediate game plan. Number 1, check those actual utilization numbers on your shared team resources today. Number 2, implement scale to zero patterns, specifically in your dev and experimentation environments. That's usually your easiest win, because idle time is always highest when developers are actively tweaking and debugging. And number 3, track your cost per million tokens over time. Because of that 1,000x price compression we talked about, last year's too expensive premium model might actually be cheap enough to reconsider for your stack today.
I'm going to leave you with the final thoughts take back to your engineering teams today. Now that you know 95% of your compute budget could literally be evaporating into thin air while you sit in a meeting, are you going to keep treating the cloud like a utility and just blindly pay the bill? Or will you step up and start actively engineering your compute down today? The tools are there, the savings are absolutely massive, it's just a matter of executing. Thank you for joining me for this explainer, and happy engineering.